I'll be more.
Oh no, you're good. Always. The
Prepared.
next time, don't want to be too prepared because it's not fun if you're too prepared. I don't get to play. I don't get to play with my food if y'all are too prepared. I can't be having that. Welcome everybody to Frankie's Open Mic, and I am Haleigh Overseth of Frankie's Podcast Network, and we are here with Dr. Joe. Dr. Joe. I like become short round a little bit every time we get to chat because that's the Dr. Joe, Dr. Joe. And we get to talk tonight about how everybody better be getting ready and rolling to their bunkers. Am I correct?
Yeah, I think so. In fact, my time is limited, so let's do this quickly so I can get out of here.
Y'all, we gotta this Armageddon thing is popping off, and Dr. Joe is ready to get to his bunker. And if you have not planned your stuff and got all of your non-perishable goods in order, then I don't know what to tell you, y'all. The asteroid is coming, and you're just done. I guess that means we all need to start an after, like it needs to be like an Armageddon party or an end of world party, right? That's what, right? So talk to us. There's an asteroid coming in my Google News feed. Do I need to be panic times?
Probably not.
Probably not.
No,
you know what? Your demeanor says to me, just nope.
No,
No.
Don't worry. So, well, we can get to the worries, the unknowns, right? The unknowns. But before I do that, I just popped in my mind one of my favorite episodes of The Simpsons from early days.
Okay.
You remember the one where the asteroid was going to impact Springfield?
I don't know if I remember that one, but I think that we have done this before where the Simpsons once again has become like the prophecy generator, like they are Nostradamus.
Well, maybe, yes. But in that, I don't want to do a spoiler, but I'm sure people have seen it. If you haven't, go and watch.
Go find it.
And my spoiler is not going to spoil it, but the asteroid is coming the entire episode, and then at the very end, it melts down until it's just a little pebble.
And that's all you get is just the little pebble that falls.
And then, of course, the violent gang of Springfield residents with torches and pitchforks runs up to the observatory saying, let's destroy the observatory so this never happens again.
So this never happens again. Oh, don't we just have that exact reaction as humans sometimes, to go way the opposite direction?
So, to get to your point.
Yes, but please, starting with The Simpsons is the right way to do it. I appreciate that, right? Like, start with that. It's edutainment. Yes. Now let's get into it, y'all. Remember your Hitchhiker's Guide to the Galaxy. Big friendly letters. Don't panic, Dr. Joe.
Yes.
Tell us not to panic.
So don't panic. I mean, on the near term, right, in the next, I don't know, generation 2, 3, we're probably okay. So I say probably because
we're probably okay. I like this.
There's a lot of stuff out there, right? And we don't know all of it, but we'll come back to that in a second. So there is stuff out there, and of course the Earth has been, bumped into and smashed many, many times over its history. And
I mean, we've all got scars in life, right? Like,
exactly.
Mother Nature, Mother Earth, she's not any different. She's been bebopping around this cosmos, and you know, now and then you fall and scrape your knee, I guess, huh?
And it's messy, right? So the solar system's messy. There's lots of chunks of rock out there.
The solar system's messy. That's a T-shirt right there.
Yeah, actually, that's a great idea. So these asteroids that are in the news recently, one of them, Apophis, I believe, was thought when it was first discovered several years ago, there was a small single-digit probability that don't quote me because I don't remember the dates here, but in the next 5 or 10 years, it might impact the Earth, and that would be a bad situation because it's large enough to cause problems. But new observations, and again, we'll get into this because it's kind of a complicated picture of how we do this. There's lots of variables, and gravity is a well-known thing, but it's complicated.
Omni's over here trying to help us not panic too. Chances of an asteroid hitting are pretty small.
Are pretty small at the moment, and certainly this one that had a very small probability several years ago. That probability is looking to be almost zero now, and so refined orbital analyses have showed that probably that particular asteroid won't hit us. It'll come very close, but it won't hit us. So
do we need to be concerned about debris, right? Because that's the next thing that the propaganda machines will make us want to be anxious about. That, okay, well, maybe the asteroid won't destroy us, but be aware of debris. Do we need to necessarily have that concern?
from the asteroids themselves, probably not. The type of, I mean, in general, there's debris in the solar system, so that's, you know,
Right,
an asteroid
again.
is debris, right? But what I'm interpreting what you're saying is there stuff coming off of the asteroid that we might have to worry about? So probably asteroids, no, but comets, yes. So, you know, comets are asteroids. As we're learning more about them, they most of them appear to be a collection of pebbles and rocks up to, I don't know, 10, 20, 30 feet in diameter, all loosely held together. So it's like a loose rubble pile.
So it's kind of like just a pile of gravel hanging out and traveling through space.
Yes.
Okay.
And, you know, in space, there's gravitational influence from the planets and from the sun and that sort of thing. But it's the closest thing to all those pieces of gravel are their companions, and so they're held together through mutual gravity and very weakly, right? So asteroid can range from that to something that might have like an ice binder mixed in with it, with that gravel and rock, or it can be a solid piece of metal. So we do know of asteroids that are solid metallic objects. Now, you know,
we really do just have bunches of space trash floating around.
Bunches of space trash. Yes,
it's amazing.
It's stuff that was left over when the planets formed, 4.5 billion years ago, that didn't form into a planet. It's planets that formed and then were destroyed very early on because it was a very chaotic place in the early solar system, and lots of debris, right? Big chunks of things smashing into each other. And so, you know, formed planets or moons or whatever that smashed into each other and broke up.
Whose space trash is it?
Whose space trash is it? It's nature's space trash.
It's nature's space trash. I mean, my sci-fi brain, and you're familiar with this, you've chatted with us enough times, you know that I like to go into the fun, wild speculation. So sci-fi brain wants to say, well, is there any way to go and we have go mine those asteroids like Armageddon, you know, like, can you, or maybe sort of in a fishing sort of way, like cast a net and catch some of that stuff, and like that's some resources that you could use, those metals or whatever's in there.
Sure. So there are, it's a difficult technological thing, but we're getting to the point where we might be able to do that sort of thing in the next 10, 15, 20 years or so. And yes, so that can certainly be done. The question is gold, for example. There's lots of gold on some of these objects, as far as we can tell. And gold is expensive on Earth because it's rare.
It's a precious metal. But
so you bring a huge
if it's just floating around in space as space trash, maybe it's not quite so valuable after all. Well, maybe we humans need to reevaluate our, designations of value in our metals.
Yeah, exactly. Now, on the other hand, gold has, whether it's expensive or not, it has utility and technology, and so that's a useful thing. So yeah, absolutely, mining of asteroids is a possibility. Rocket fuels can be made of many things, but a primary component is water. And so if we find ice in asteroids or comets, more likely, you could use that object to produce rocket fuel, and so you could use that as a waylay point to go to outer reaches of the solar system.
I'm just now writing then a story where there's a brand of water that we have. It's like you can get Aquafina, which is like made from Earth water, or you can get Cometina, and that's been made from comet water, and that's like this expensive fancy water that we have from Earth now is the comet water.
One day, maybe. Yes, absolutely.
I see us humans and our just obsession with commercialism and merch. I see us doing it.
Yeah,
and it'll be a fun time party. Guess what? I hope it comes in a pretty pink label. I'll drink it.
I can see that happening
Love it.
very, very shortly as well. So the debris that you're talking about mostly comes off of comets, and we have meteor showers um, throughout the year, and these meteor showers are little pieces of dust, basically, that crash into the Earth's atmosphere and burn up, and then we see them as a streaking meteorite.
We do
And
have a
most
question. We'll come back to this
okay,
from Adam Twister, like the space age. That's a whole other conversation that I'll want to come back to.
sure, okay. So these particles of dust that crash into the atmosphere and burn up and cause meteorites that we gaze at and look at and wonder and in awe, because they really are quite amazing. That's usually debris that's coming off of the comet. The comet is a gaseous, icy body that, as it comes close to the sun's heat primarily melts off the surface, and that flows off, forming the tail of the comet, which gives the comet its kind of its name, right? And then there's a debris cloud that goes off into the solar system, and if the Earth's orbit happens to pass through that debris cloud, we will experience a meteor shower. And so most of the big meteor showers are caused by comets that periodically come through the solar system. And again, those particular ones that happen to cross Earth's orbit. Okay, so there's all sorts of
Well,
stuff
and
out there.
there's all sorts of stuff, but also these comets that normally come around, and like the Taurid meteor stream is one that we've talked about before too.
Yeah.
It's really not unusual,
Right.
for there to be things hurtling towards Earth at any given time,
Yes,
right?
right.
Like it's a fairly normal occurrence. So
yes.
again, another reason not to panic. Like, there are a lot of these things going on, but we are observing them and we are aware of them, and it's kind of like you just deal with the hazards on the road sometimes. That's part of what you do when you get on that death machine and drive the car with other people who get to make decisions outside of you, right? You just kind of have to be on that ride.
Exactly. And so, there's lots of stuff hurling at us. Space is a big place, though. And so, the likelihood that any one object is going to impact us is very low. But it happens. And it happens periodically, and I suppose you could say frequently over the history of the Earth on astronomical timescales, right? So then the question is size, right? So if it's a house-sized chunk of rock or ice or solid metal, that's going to have different effects as it burns through the Earth's atmosphere. Because when it comes in, whatever comes in through the Earth's atmosphere is going to be melted to some extent, because they're moving at very high velocities, and when it hits the atmosphere, there's a lot of friction, and so that burns off a lot of the material. So a loose collection of rubble is going to break apart when it hits the atmosphere, compared to something that's of a similar size that's a solid piece of nickel, say, right? That's going to melt as well, but not as readily as a loose collection of rubble or a big chunk of ice. So we have to.
So I'm also thinking, in my mind, I'm kind of thinking of, I know there's an event that sometimes gets pointed to. I want to say it was maybe in Russia, where there was kind of almost an impact, right? Like, right. So can you maybe talk a little bit about that, some of this stuff, it burns up as it comes through the atmosphere. It might not necessarily impact the ground, right? But it can still cause. Can you talk a little bit about like what it is that happens when that causes like a damage situation, even though there's not an actual impact?
Sure. Well, so I more recently in Russia, 10 years ago or so, there was the Chelyabinsk event, I think, which was a largish object. Again, I don't have the
dimensions or the numbers, right?
But
like
tens of meters, say, and that object burned up in the atmosphere, exploding basically. But that explosion, right, blew out windows, and hundreds of people were injured by flying glass and that sort of thing. So it doesn't have to come to Earth and cause a huge crater to cause damage.
Right.
There's a lot of energy in these things when they explode, and even if they explode at high altitude, you're still going to get some sort of effect, maybe on the surface. I think what you were referring to originally was the early in the 20th century, the Tunguska event in the middle of Siberia. And if you're not aware of that, our listeners are not aware of
Well, I was
that.
gonna
Look it
say,
up.
I like both of them do come to mind just because I know that there are things that are pointed to in these sort of conversations, right?
Yes.
When folks start talking about the potentialities of, you know, these things hitting Earth, and like, and that's another topic that we can get to if you want to switch to it, like in a once we kind of get there, the Graham Hancock sort of visionary, that kind of like his theories and things on that we were gonna canvas your views on, because again, I do find it very fascinating. But yes, please continue.
So no, that, I mean, it's all great, of course. So the Tunguska event, it's unclear exactly what it was. It might have been a comet, but again, that's something that there was an airburst at altitude, and luckily for us, it occurred in the middle of Siberia, in the middle of nowhere. But it flattened trees for a large distance, and the explosion was heard in London, so thousands of kilometers away. And then it caused, because presumably a lot of dust went into the atmosphere, it caused funky sunsets for some time afterwards. And Soviet scientists in those days, well, they wouldn't have been Soviet, they would have been Russian, but I think Soviets later went out and trekked out in the middle of nowhere, and and found all the trees
Like you
pointing
do.
away. Yeah, exactly. But there was no object remaining, so no crater or anything, but the signs of the explosion. And this sort of thing happens frequently on Earth, but of course, remember the majority of the surface of the Earth is covered in water.
I
So
was
if it
gonna say, so
happens over
you're
the
probably
ocean,
like, you have those situations. It's not. Do we have systems that are tracking things like that happen? I imagine we do, with the various different, I'm thinking like USGS from, my own
sure,
wheelhouse of experience or knowledge. But
seismometers
obviously,
and
right, things that happen over the ocean are gonna, the water's gonna absorb some of that vibrational impact or energy,
right,
right? So
right,
also less reason to panic, right?
yes,
Because, like, thank you to the oceans and the water for absorbing so much of the impacts of things that come from space. We appreciate you.
yes, absolutely.
Hmm.
So the Earth is a target. You can think of it in the target in the solar system, but it's small, and space is big. And if you are eventually targeted, then it's more likely that something is going to impact in the ocean, because there's more of the ocean. I should also, it's a little bit further afield from what we're talking about, but there's tons and tons of dust, interplanetary dust, that's falling on the Earth every day. Now, that's not dangerous. It's just stuff that's
That's
coming in.
such a funny, interesting thought, that, like, don't feel bad about your housekeeping. Even Earth has dust
Yes,
fallen on it from the
yes,
solar system.
exactly.
Again,
Huge
solar
amounts.
system is messy and dusty.
Yeah.
That's kind of an
So,
interesting, fun little thought.
and it truly is dust-sized things, right? So very, very
Hmm.
small particles, and that's going to be more common, that very small stuff. And then the larger objects are are less common. So the question is, what is the object that's coming in? Because the composition is important. Like I said, if it's a loose collection of rocks, or it's a chunk of ice, or it's a chunk of metal, that's going to have for the same size mass, it's going to have a different impact, literal impact on Earth, right? One may burn up in the atmosphere, while one continues to the surface. And then the question is, how big? And because we're talking about very high speeds, so lots of energy, you don't have to be very big to cause a tremendous amount of damage,
Right.
right? So, I mean, we're not talking uh, things that are 1,000 miles wide smashing into the Earth. We're
Right. We're
talking
not.
things that are maybe football field size, that are smashing into the Earth, causing catastrophic consequences.
Football fields, not New Jersey. So
Right.
that,
But it
that's
would
what we're
take
looking
out
for.
but it would take out New Jersey, a football
So
field.
nobody throw a football field at New Jersey from
Exactly.
space, right?
And
Jersey, nobody's trying to come for you. Again, we're not panicking.
And so, it's obviously the impact that causes the problem, but it's mostly the after effect of the impact. So a thing comes down and it smashes into the earth and causes a crater. Well, it's throwing up a huge amount of earth. It's excavating that crater, and that goes into the atmosphere and causes dust blocking the sun for years and years. So you get into kind of a nuclear winter scenario where temperatures plummet and crops fail. Of course, when it impacts, it causes fires, the fireball that would travel out for thousands of miles and burn everything in its path. So I'm thinking of what did it to the dinosaurs, right?
Right.
5 million years ago.
And any of the, I mean, are there, again, it depends on, I imagine, the composition of it, but any sort of like potential radioactive energy or like energy that would, the same way radioactivity hangs around, anything that would sort of like cause chemical changes or along those lines that would be problematic, or is that not something that you expect quite as often with that kind of an impact?
No, I wouldn't. Yeah, I wouldn't expect that sort of thing. It's more the immediate effect of huge fires from the fireball, and so you're burning a continent.
Well, see, now there's all kinds of pluses here because, again, not so very many things to worry about. It's not radioactive or nuclear or anything like that. And there's so much of planet Earth that's on fire right now all the time anyway, because she's just remodeling, apparently, right?
Yeah.
So just all the more reason for all of us to just remain calm, right?
To chill out. Yes,
to chill out.
That's right. Well, maybe.
Maybe. I mean, you can choose to panic if it's more fun for you to panic. We don't want to take away your fun.
Yeah.
By all means.
Who are we to do that, right?
Who are we to do that? If you want to, like, Armageddon was a great movie, fun time, I understand. But for those of us who don't want to panic because 24-hour news has got us on like a, cortisol drip all day, every day. Well, Dr. Joe says everything's going to be okay.
Everything's okay for now.
It'll
happen eventually. It'll happen eventually because statistically it can't not happen.
And it's happened before in the history of our planet.
Yeah.
And, so if we could maybe like switch just gears a little bit and shift into that, right? Like, so that's something that I do find fascinating about, Graham Hancock's work and the sort of investigative journalism that he does, archaeologically speaking, I guess you would say. But he does talk a lot about the idea of like an ancient human civilization that could have existed prior to, and correct me if I say any of it wrong, but like the Younger Dryas period when we did have a massive impact 13,000 years ago, right? That would have presumably caused things like massive flooding and things like like you're saying, nuclear winter scenario. And so talk to me a little bit about this or the science of it anyway, and what we know right now, I guess I would say, about that time period and the effects that it had on Earth at that time.
So it's a little bit outside of my
say hi to Matt. What's up, Matt? Hi, friend.
A little bit outside of my expertise, and so maybe we can broaden this and talk about how these sorts of events might have had influence on life on Earth in general. But I will bring up something intriguing that later on. So
okay,
remind me in case if I don't mention something intriguing, remind me.
Well, it's all intriguing to me. So everyone in the comments, make sure that you like put a pin in that. Extra intriguing. We got to get to it. All right.
So the question is, right, we have these bursts of evolution and development, and we have in the fossil record, we have extinction events, right? And so the question is, well, we're almost certain, 99.9% certain that, well, we know that there was an event 65 million years ago, right? And, we now know that dinosaurs weren't flourishing up to the second of impact, and then they didn't exist. Well, they didn't exist afterwards, but that it wiped them out completely. They were struggling for other reasons, and this was kind of the event that ended them. Although I'm
And
hasten to add that birds, of course, are dinosaurs. So.
right, chickens are dinosaurs. Yes.
So we see extinction events throughout the history of life. And the question is, were those all caused by impacts? And the answer is probably no, but there were certainly some of them that weren't. It's not quite clear yet, and we're not clear because there's no direct evidence, so we're not finding craters and other evidence of external impacts. Now that's not surprising on Earth because we have
Again, all the water.
Well, the water and erosion and that sort of thing. So you have a big crater, and it gets over a billion years it gets covered up in sediment, and it disappears.
It's flooded from other things, and who knows what.
So in the younger Dryas, that can certainly have impact. Now, so why? Now, is it a stressor that causes mutations that are beneficial? Is it an extinction event that clears out a biological niche that allows other biological entities to come in and take over? Right? So
so sort of natural selection on a cosmic scale.
Yeah, well, yeah, and influenced by cosmic stuff. So the dinosaurs were in every ecological niche, and so they're competing with early primitive mammals, and they're getting along, but the mammals can't take over because the dinosaurs are in those niches, and they're top predators or whatever, right? So you wipe out the dinosaurs, and now you have these niches that are open, and other things, mammals,
other forms of life get to thrive and evolve in different ways.
Exactly. So the intriguing thought. So I remember the intriguing thing. Now this isn't, but so this opens the discussion a little bit broader because we're talking about asteroid impacts and that sort of thing. But there are other astronomical objects out there that can be even more problematic. So asteroids don't keep me up at night, but merging neutron stars do.
Talk to me about merging neutron stars.
So
what's a merging neutron star? That sounds exciting. That keeps you up at night?
Because these are the sorts of things that you can't necessarily find until it's too late. I mean, you could say that an asteroid that's coming to the Earth that's going to, wipe out civilization, you might not find it until it's too late. But we're doing surveys. I should hasten to add in our main discussion that, and I don't speak for NASA, so that's the caveat. But NASA has the mandate from Congress to identify all the asteroids up to a certain size, and these are basically problematic asteroids. For us,
right.
And so they're doing surveys, and they haven't detected all of them, and you question, well, how do you know if you've detected them all? And so
right, again, space is a big place.
Exactly. But the reason is, number one, to at least warn, hey, we've identified this thing that in 50 years it's going to impact the Earth, and so maybe we'll have some time at least to do something on Earth. Or more positively, can we do something to move it? And so there is some technologies that we are studying now. It's a difficult thing to do, but there are technological possibilities of tweaking the orbit of a thing that might be impacting the Earth just enough so that it avoids us. Now, you need a long time to be able to do that because the tweaks are minuscule. So if you have 100 years, that something is going to impact the Earth in 100 years, you can go out there potentially, and with a small amount of energy, you can make a tweak now that 100 years later will that will grow into something larger. If you only have 2 years, then your options are limited, and so
and more room for error, I suppose, too. Yes. Right? Because pushing it off of Earth's trajectory does mean that it's a potential shift into something else's trajectory that could be problematic in turn, right? Domino effects.
Exactly. I'm going to bring up a parenthetical. We've talked about science fiction and The Simpsons, but so I'm a Star Trek
Yes.
Star Trek in general, but original series, as you know. And just last night, I won't put a plug for the station, but there was the episode where exactly this sort of topic was in play, in that an asteroid was coming to a planet that had been seeded by an advanced civilization, but also because it was in an area where there were lots of asteroids, they put a device that would, destroy the asteroids that were coming.
A nice little filter.
Yes, it's called the Paradise Syndrome if you want to look it up. So it's
the Paradise Syndrome.
Yes.
Sounds lovely.
So asteroids are just one of many astronomical bad news events.
Bad news events. Well, tell me more about these. Say it again. The colliding,
the merging neutron stars.
the merging neutron stars.
So neutron,
and I get excited about the sort of like that's the macrocosmic, and it you've got the micro sort of quantum particles scale. So like, can you paint me a picture on that level?
Sure. So neutron stars are the end state of a star much more massive than the sun. It lives through its life relatively rapidly and it explodes as a supernova. Supernovae, by the way, are another problem for life on Earth. We'll come back to that.
Okay. Is this that keeps you up at night? Supernovas?
Not so much with supernova, because we know the sort of objects that cause supernovae and we know where they are. So the nearest such object is Betelgeuse, the star Betelgeuse in Orion.
What's that? Betelgeuse.
Yeah, well, there you go.
Have to. Right?
But go out and look at Orion, and well, not now, but in the winter, and the shoulder of Orion is that bright red star, and that's Betelgeuse. Betelgeuse is a star that will explode, maybe has already exploded as a supernova. It'll be fantastic if it does. It's relatively nearby, 700 light years. But let's come back to that. So
come back to the party that we're going to set up to watch that happen, right?
Yes. So neutron stars are, when these big stars explode, they can leave behind basically the crushed core, their crushed core that's been squeezed down into something that's the size of a city, 10 miles in diameter. And the forces are so strong that basically they, the core of the star is made up of electrons and protons, like everything else is. But all that material is squeezed together so tightly that the electrons are pushed into the protons and they form neutrons. And so the entire core of the star, electrons and protons, catastrophically turns into neutrons, and you have a very small, dense, extremely dense object. So this is what's called a neutron star, and there are lots of them out there because there are lots of stars that produce them when they die. So on their own, they're okay. There's nothing particularly, they're interesting, but there's nothing particularly problematic about them.
Okay.
But if they happen to be in a so-called binary system where the two stars were orbiting each other gravitationally, and then eventually form neutron stars that continue to orbit each other, they can get in a situation where they lose energy, gravitational energy, and they spiral into each other and then merge.
Okay.
Collide. And in doing that, they release a tremendous amount of energy and they explode, basically.
And our sun is of a binary, right? This is something that, or
the sun is isolated.
Okay.
So it's very unusual because most stars are in binary or multiple star systems, but our sun is not unique, but it's in a minority of a single star. Now, the argument is that if Jupiter had a little bit more mass, it would have been the second star in the system.
Oh, that's interesting.
It's not quite a failed star, but if it had accumulated more mass as it was forming, it would have collapsed and formed a star, and we would have had a binary star system, a companion to the sun.
That's a very interesting, even rabbit hole in and of itself to go down, because then how does Earth look different if Jupiter had become a sun? That's fascinating.
Yes.
I could keep you busy for a whole episode with that whole thing. That's
Absolutely.
that's a science fiction story waiting to be written too. I love it.
Yes. Yes. Absolutely. So the scary thing is we can't necessarily detect these binary neutron stars, so they could be traveling around us. In fact, there is one that's relatively close, 10, 20 light years from the Earth. And if it were to merge and explode tonight, we wouldn't be here.
That's fascinating. Live life like there's no tomorrow, because I mean, there could be a big explosion in the space sauce
Yes.
and we'd all just be vaporized.
Yes. Now the
Well, there's no reason for you to lose sleep over that, because there's nothing you can do about it anyway.
well, I know, but
You know, why worry?
exactly.
There we go. Don't panic, because why worry? If it's gonna be a like the plane's going down situation, well, it's gonna be over soon.
No, that's right. So
Right.
there are these sorts of things out there. I don't want to worry people, but the universe is a violent place. But
The
this
universe is a violent place.
it is, right? I
Yeah,
mean,
yeah, this is true. That's how all of our stuff gets created.
but so that long winding path to this intriguing observation that um, when so either the merging neutron stars, or just the massive stars that explode as supernovae. A supernova is, speaking of violent events, they are extremely violent events. They're probably the most energetic, among the most energetic events, astronomical events in the universe. For a short period of time, an individual star exploding outshines hundreds of billions of other stars in its galaxy, because there's a very efficient conversion of matter to energy through the E equals mc squared, Einstein's law.
The universe is violent but efficient.
But efficient, yes.
There is
And
that.
so you get this massive explosion, you get the creation of lots of elements, radioactive elements, in particular, and lots of energy. And so, in particular, these supernova produce a radioactive isotope of iron. And if our listeners are interested, it's iron 60 is the isotope of iron, which
Okay, interesting.
it's not very radioactive isotope, and it has a very relatively short half-life. So that means its radioactivity disappears relatively rapidly. And as far as we know, and I think this is a true statement, it's only produced in supernovae explosions. So studies have been done of cores from the ocean, the ocean
Right.
floor cores,
Mhm.
and radioactive iron 60 has been discovered. And so what does this mean?
Yeah.
It means that the solar system had to have been very close to an exploding star, a supernova, and in fact, it had to have traveled through the debris cloud shortly after the supernova exploded.
You know, it's kind of exciting to think now, again, science fiction, right? Thinking of our solar system as sort of like an entity of in and of itself that just was like, I'm going to go surfing and ride that supernova wave, and I'm going to make a bunch of planets, and I'm going to there's going to be humans that are going to develop on one of these planets someday, and it's going to be wild.
So to that point, this because we can measure the quantity, and we can determine, well, they can determine the age from the sediment for other reasons, but they can also determine the age of the iron 60, and it's about
Mhm.
2.5 million years old. So that means we were within the debris cloud of a supernova, which isn't a good thing, because that means the supernova occurred relatively nearby the solar system,
Right.
right? If it's too far away, over time it'll eventually disperse into the galaxy, and when we get to that point, there's nothing there. So it had to be very close to the Earth 2.5 million years ago. And there's a lot of ionizing radiation that comes from supernovae and charged particles that are very problematic to biological systems. Now,
Okay, so a 2 million years ago supernovae explosion.
well, what happened 2 million years ago
Right,
on
that's
the
what I
on
want
the
to know.
on the plains of Africa?
Cosmic rewind, right?
Well, yeah, primate developing into something, different than they were before.
Than they were before. I mean, and like Iron 60 jumping on into things, a lot of energy being
Yeah, lots of
thrown
mutation.
about. Hmm.
So I'm not the first person who's made this connection by any means. I'm not sure if there's been any research in this regard. I just find it quite intriguing, and I'm not necessarily saying that
I mean, is
that
there
event.
other are there other ways that you could, and this is going to become a strange question maybe, like how do you, because in some ways you're already studying history
Mhm.
as you study astrophysics, right? Because
Yep,
you're
it's always in the
watching,
past.
it's always in the past, right? That's all that you can observe. That light is from the past.
Mhm.
You know, so how do you kind of, I don't know if you would say, what's the detective work? What is the work that you would do to determine something that would have happened that doesn't necessarily have that light evidence for you to observe? How do you look for what did happen?
So we wouldn't. Well, we have the evidence from the Iron 60,
Right.
right? So we know definitively that the solar system traveled through this uh, supernova. It's called a supernova remnant. It's the end state of the after the explosion, and it lasts. Supernova remnants last 10, 20, 30,000 years before they dissipate into the galaxy. So it's a astronomically short event and short duration events. So we literally would have had to be very close to the supernova. So we have evidence of that through the Iron 60. Now the speculation of did that supernova event cause? I mean, we know what the supernovae do, right? Not only are
Mhm.
they producing the Iron 60, but we know the amount of ionizing radiation that comes out of them. We know the impact of that on Earth's biosphere, its atmosphere, right? Um, it's highly speculative to say, hey, did that potential mutation event, have any impact on early primates in the savannas of Africa 2.5 million years ago? I don't know.
And help us develop into the wild bunch that we are today.
Yeah. So, evolutionary biologists, I suppose, would have to come to play with that. Maybe they can
Is
tell
there
from DNA. I don't
anything
know.
is there anything, so, I mean, is it only just the effects on Earth that you can look at in order to sort of determine the event that could have happened? Is there not, like, other observations you can do in space to sort of, I guess that's my question. Can you look out there and try to find where the thing was or what the thing was, or is that energy having dissipated? It's just the light is gone, the energy's gone. You can't say for sure what it was.
That's right. And if something's left over, say a neutron star or a black hole, these supernova can produce black holes as well. They're moving, right, just like we are. And so, I suppose you could go back and say 2 million years ago, we know how we're orbiting around the galaxy. 2 million years ago, we were kind of in this location, but whatever was there with us wouldn't be there, wouldn't be there, wouldn't be hanging around any longer. So yeah, we can't point to any particular object. Just like when the sun formed, it was not alone. Most stars form in groups of stars that range from dozens to hundreds or thousands of stars being formed together. So the sun has lots of siblings out there, but there's no way that we would know.
Siblings. That's
The,
such a nice little thought. Our son has siblings. I
yeah,
like that.
absolutely. Yes, probably lots of them. But we can't point to any particular star and say, oh, that was the sibling of the sun, because
Yeah.
over that 4.5 billion years we've been moving around the galaxy, and so have they, and they've had slightly different gravitational influences, and so you can't put the clock back and and look that way. So no, sadly, we're not able to do that.
Lots. It is an interesting thoughts. Lots of interesting thoughts. I do. That is a fascinating thing, and that's. I love these conversations. I really do, because it does get to that place of, as much as we think we know, we don't know it all.
Yeah.
And that's such a, I think it's a valuable place to be in. I think that, that's, again, science is exploration, and that's the whole point, is to explore what else there is out there that we do not yet understand. The mystery of the universe is the fun of the universe.
Exactly. And astronomy is I was going to say somewhat. You can't say somewhat unique, but I think we are unique in the sciences in that we're still in discovery space, and by that I mean, we have old friends that we've studied for decades, hundreds of years, and we know a lot about, and we continue to know to increase our knowledge. But there are also many more things out there that we have no idea what they are. And tomorrow I go out and I make an observation of an old friend, and off in the corner of the image there's something completely new that I hadn't expected and no one had ever seen before, and now we have to explain it. Or we start observing in a different wavelength that we've never observed before or hadn't done much, and we look at an old friend and it looks different, and it's different in a way that is not consistent with how we thought we understood our old friend, right?
That element to me is very interesting. The new perspective of an old friend sort of thing, right? Because, and this is maybe getting a little, again, going off into some of the fun things that I like to think about. So when you look at, the friends that we know out in space, we are using our current understandings of observational technology, which all come from our capacity to observe, right? And so one of my favorite, little things in the scientific community is that argument of can we feel wetness, right? We've had this conversation before too. So it kind of becomes an interesting thought to me, the idea of there's so much of our reality that we don't have the correct receptors in our own sensory organ selves to observe or receive or translate the frequency information of the way that our eyes translate light and our ears translate sound, right? So we have to come up with sometimes these scientific instruments that have the capacity to measure these things that are not measurable by our sensory organs, right?
Yes.
And so it becomes something that is really very exciting to think about. And we've talked about dark matter before and dark energy, right? That idea that there's so much of our reality that we don't have the capacity to observe, and there's so much. So what's maybe some of your favorite things then about what are some of the newest things that we can use, technologies we can use to measure our old friends and see them in a different light? What are the fun new things that we're discovering about old friends in the cosmos that we didn't know before because we didn't have the tools to see it?
Well, so a good this is a little dated. I'll come back to something that's going to happen soon.
Okay,
and
I love it.
we can discuss that, a new capability. But so earlier in my career, I was an X-ray astronomer. I've worked with lots of wavelengths, but I was in working with X-rays as well. And at that point in my career, long ago, we had X-ray telescopes. So you need satellites to go above the Earth's atmosphere because the atmosphere blocks X-rays. Luckily, right? And by
Luckily,
the way,
thank you, Mother Earth, for
exactly
taking care of us so well.
This is why space travel is so difficult and dangerous, because there's lots of gamma rays and X-rays and things that are being blocked out by the
There's a little bit of that, you can hear your mom's voice in your head. Okay, go ahead. If you think you're safer without me, you go ahead.
Exactly. Yes.
Right.
So we have these X-rays are very difficult to collect because they're high energy, and optical telescopes have a mirror, as I'm sure we've all seen, and the light comes in and it bounces off the mirror and it bounces off a couple of mirrors, and those little photons are low energy, and we can manipulate them by changing the shape of the mirror and that sort of thing. Well, X-rays are really energetic, and so if we used a mirror like in an optical telescope, it would just go right through it, right? So the technology, you require relatively advanced technology, much more advanced, to work with X-rays than you do other wavelengths. Certainly,
Mhm.
other lower energy wavelengths like visible light.
Mhm.
So, we've had X-ray satellites through the 70s, but it was really kind of in the middle 80s that the technology advanced enough that we had these powerful X-ray telescopes. And I like so early in my career, I was at that change of kind of the old X-ray technology to the new technology. And the old technology would give us 5 or 6 or 10 photons per astronomical object. So literally, I mean, when you're observing in the visible, you get millions and billions of photons on an image.
Mhm.
But literally, we're counting 5 to 10 X-ray photons. And for another discussion, you can learn a lot with 5 or 10 X-ray
I was
photons
gonna
because they
say that
carry a lot of
seems
information with them.
that's you get very sort of granular, right?
Yeah.
And specific. So you can get some like really like up close details. That's very interesting.
Kind of. But the new technology that came on was turning X-ray astronomy into something that was like visible astronomy. We were getting lots of photons from the astronomical objects. So, to your point, there's a type of galaxy that we call an elliptical galaxy, and it's made up of mostly older stars. And when I was a graduate student, we learned that elliptical galaxies did not contain any gas. Uh,
Okay.
the gas had all been used up into stars, and there was nothing left. It was just, these elliptical galaxies were just
The
stars.
old souls stars were hanging out and they
Exactly.
used up all the elliptical energy.
Yes. And, as opposed to galaxies like our Milky Way, which is a spiral galaxy that has stars and a lot of gas and dust. Okay. So we turn the X-ray telescopes onto elliptical galaxies to study them. And lo and behold, there's a lot of gas in the elliptical galaxies. It's just that it's very hot gas, millions of degrees. And
Oh,
million-degree gas emits X-rays, and that's the only way you can see it.
so that's the tropical tourist location in the cosmos.
Kind of, yes.
Got you.
So here we go and that was literally completely rewriting textbooks. From these things don't have any gas because when we look in the visible, there's no indications of gas. You turn the X-ray telescope, which is new technology, and you say, hey, there's lots of gas. It's just that it's very,
Actually,
very hot.
turns out.
So now we have to explain why that's there. And so, you learn more and you get a refinement of understanding of how the universe works. Something that really exciting coming up though, and again we can
I was gonna
discuss
say
this later.
it's just it's like because it is. That's why give us a little teaser trailer here because I
So
know we're
yeah,
coming up on an hour and we can
yeah,
definitely
exactly.
have you back to tell us more about because I need to know about the things we could find out about old friends that we don't know. How exciting!
Well, so the teaser is that there's a telescope that's going to be coming online in next year or so. It's called the Rubin Observatory, Rubin, after fantastic astronomer Vera Rubin, who discovered dark matter in the early
Okay.
70s. And so this telescope, the Rubin Observatory, is designed to do continuous surveys of the entire night sky visible from its location. And it takes 4 nights to be able to image the entire night sky. But it does this continuously. And
Mm-hmm.
so the reason it's doing this is because it will detect astronomical objects that we call transients that um, light up and then may disappear. So they may light up for a couple of minutes, a couple of hours, a couple of days, but then they fade and we don't see them. So
And you call them transients.
because they're only there for a short time. So remember when we make astronomical observations with almost any observatory that we're doing, we're basically looking down a straw, right?
Mm-hmm.
And so we're looking at our target object down a straw, And all around us, there's stuff going on that we're not seeing because we're not observing there.
Right.
And we can't. So we've done surveys of the entire sky, but these are usually long-term things. So you take an image, and then a couple nights later you take another image, and then eventually over 10 years you've imaged the entire night sky, but you're still missing these so-called transient things. So the Rubin Observatory is designed to pick up normal objects that we normally see, as you would with a regular telescope, but also these events that burst or pop into
The blips or
existence.
the glitches in the matrix, if you will. And what was that?
Exactly. And we are expecting 1 to 10 million such objects per night.
Per night.
So some of these are going to be asteroids. Some of
Sure.
them are exploding stars, like the supernovae that we talked about. There's other sorts of objects that we know about that do this sort of thing that we just haven't seen large numbers of them. I mean, we've seen onesies and twosies here and there, but the vast majority of them are almost certainly going to be things that we have no idea what they are. And so
that's very exciting. All of the new puzzle pieces you get to play with, and what else can we put together in this vast cosmos that I'm so excited to find out more about that. Like,
Yep.
how do I'm calling it in from the universe? Like, let's all be able to be at the opening of the Rubin Observatory with Dr. Joe and do a live podcast there, because that would just be amazing.
That would be amazing. Yes.
I would love it.
That's a
lot of, and it's in, let's go to Chile. Like, eat some awesome, delicious food, meet some really fun locals, do a podcast at the Rubin Observatory, and watch some amazing fireworks in the night sky just reveal themselves to us. How spectacular.
That would be fantastic. Yes.
Oh, that would be so fun. Thank you so much. I know, listen, I appreciate it. It goes by so fast when we get to chat about these things that I just am so endlessly fascinated and enamored of. That's why I write my science fiction stuff, because I just love those mysteries that are out there in the cosmos. There could be any kind of wild party going on.
Yeah. Yeah. Isn't it great?
It's a beautimous thing. I really do love it. Dr. Joe, thank you so much for joining me on my Frankie's Open Mic new podcast, and being brave and joining us for the live sauce here. And I do hope you'll come back again. And I do hope we get to go and hang out at the Rubin Observatory. I think it sounds like it'd be a party.
That would be a blast. And thank you for having me. Yes, it was fantastic.
Thank you. And thank you, everyone, for joining us and popping into the comments. And thank you, y'all who watch later. We appreciate you here at Frankie's Podcast Network. And Dr. Joe, our resident astrophysicist, thank you for joining us.
Thank you. Take care.